Dear students, welcome to the fourth semester. In this semester, the complementary chemistry topics comes under physical and applied chemistry. Let us start with the first module, colloidal chemistry. Thomas Graham is regarded as the father of colloidal chemistry. He divided the particles into two classes, crystalloids and colloids, during his experiments on the diffusion of one liquid into another. According to him, crystalloids have high diffusibility and colloids have low diffusibility. He devised dialysis, a method for separating colloids from crystalloids, and also proved that the process of liquid diffusion causes partial decomposition of certain chemical compounds. Colloids is a Greek word meaning glue-like. Colloids are substances with particle size in between 1 to 1000 nanometer, and these particles cannot pass through the semi-permeable membrane. The dispersion of starch in water is an example for colloids. Before discussing about colloids, let us see what is a suspension and a true solution. A suspension is a heterogeneous system in which the average particle diameter is greater than 1000 nanometer. The particles of a suspension settle out upon standing and most of them are visible to naked eye. The example for suspension is sand in water or barium sulfate in water. We can see the particles of sand or barium sulfate when suspended in water. At the same time, a solution is a homogeneous system. The average particle diameter is less than 1 nanometer. It lies between 0.1 to 1 nanometer. The particles do not settle out upon standing and they are usually not visible to naked eye. The solution of sugar or salt in water is an example for true solution. We cannot see the sugar particles or salt particles when dissolved in water. The difference between a solution and a suspension is easily understood by filtration. The particles of a suspension can be removed by filtration. The small size of solute particles in a solution allows them to pass through the filter paper, and the particles of a solution cannot be removed by filtration. In the figure shown here, when a colored suspension is filtered, the filtrate is clear water and the particles are collected in the filter paper as the particle size is bigger than 1000 nanometer. Whereas in the case of true solution, when the solution is filtered, the particles pass through the filter paper and the filtrate retains the color of the solution. A colloidal system is a heterogeneous system consisting of two phases. The first phase is the dispersed phase, which consists of colloid particles having diameter roughly in the range 1 to 1000 nanometer, and the second phase is called the dispersion medium, which consists of solvent molecules or medium in which the colloidal particles are dispersed. Colloids have particles smaller than that of in suspension and larger than those in the solutions. Thus, colloids are intermediate systems between a true solution and a suspension. These intermediate sized particles cannot be retained by the filter paper and they do not settle out with time. The colloidal particles have much lower rates of diffusion as compared to the particles of a true solution. In the solution, the particle size is less than 1 nanometer. It usually lies in the range 0.1 to 1 nanometer. In the case of suspension, the particle size is always higher than 1000 nanometer. A colloidal system is a heterogeneous system in which the particle size lies between 1 to 1000 nanometer. Classification of colloids. Colloids are classified into different types based on the state of dispersed phase and dispersion medium. Another classification is based on the affinity between the dispersed phase and the dispersion medium. In the third classification, it is based on the nature of the dispersed phase. So we will discuss about the first classification, the classification of colloids based on the physical state of dispersed phase and dispersion medium. So we know there are three states of matter: gas, liquid and solid. So if the dispersion phase and dispersion medium are gas, liquid and solids respectively, we will get 9 combinations of colloids. But in the case of gas in gas colloid, gas in gas is not considered as a colloid. It is considered as a mixture. It is gas completely diffuses into another gas. So it is considered as a homogeneous mixture. So neglecting gas in gas, there are 8 different possibilities. Those are when the dispersed phase is gas and the dispersion medium is a liquid. That is called foam. That type of colloid is called foam. Best example is the soap foam. When gas is dispersed in the dispersion medium solid, it is called solid foam, and rubber, cake, pumic stone, etc. are the examples of this type of colloid. When the dispersed phase is a liquid and dispersion medium is gas, it is called liquid aerosol. The best example is mist and fog. When both the dispersed phase and the dispersion medium are liquids, it is called emulsion. Examples are milk, cod liver oil, etc. When liquid is dispersed in a solid, that is, when the dispersed phase is liquid and the dispersion medium is a solid, the type of colloid is called a gel. Examples: cheese, jellies, etc. These are the 3 types of liquid aerosol, emulsion and gel are the 3 types of colloids in which dispersed phase is a liquid. When the dispersed phase is a solid and the dispersion medium is a liquid, it is called solid aerosol. Similar to liquid aerosol, it is called solid aerosol. Smoke, dust storm, etc. are the examples of this type. When a solid is dispersed in a liquid, it is called sol. When a solid is dispersed in a liquid, that is, the dispersed phase is a solid and the dispersion medium is a liquid, it is called sol. The colloid of gold dispersed in water is an example for sol. Gold sol is the best example for solid dispersed in liquid. When both the dispersed phase and the dispersion medium are solids, it is called solid sol. Examples: precious gems, colored glass, etc. These are the different types of colloidal classification based on the state of dispersed phase and dispersion medium. Next classification is based on the affinity between dispersed phase and dispersion medium. A colloidal dispersion in which the dispersed phase is a solid and the dispersion medium is a liquid is called sols. The colloidal dispersion of starch, gelatin, gold, etc. in water are the examples for salts. Salts can be broadly classified into lyophilic salts and lyophobic salts depending on the affinity between the dispersed phase, which is a solid, and the dispersion medium, which is a liquid. Lyophilic means liquid loving, lyophobic means liquid repelling. like what we say hydrophilic and hydrophobic, which is water repelling. Hydrophobic means water repelling and hydrophilic means water loving. So coming to lyophilic salts, it has greater affinity between the dispersed phase and the dispersion medium. As it has greater affinity, it is very stable, reversible and can be easily prepared. In lyophobic salts, there is very little affinity between the dispersed phase and the dispersion medium. These salts are less stable compared to lyophilic salts. Lyophobic salts are irreversible. Special methods are required for the preparation of lyophobic salts. The particles in a lyophilic salts are heavily solvated, whereas the particles are poorly solvated in lyophobic salts. Lyophilic salts, the stability of lyophilic salts are not affected by small quantities of any electrolyte, whereas small quantities of electrolytes can cause the precipitation of the dispersed phase in the case of lyophobic salts. Lyophilic salts have a surface tension lower than that of the medium and a viscosity higher than that of the medium. In the case of lyophobic salts, the surface tension and viscosity are comparable to that of the medium. Dispersion of starch, gelatin, etc. in water are examples for lyophilic salts. The dispersion of gold, arsenic sulfide, ferric hydroxide in water, etc. are the examples of lyophobic salts. Colloids are classified into multimolecular colloids, macromolecular colloids and associated colloids based on the type of the particles of the dispersed phase. Multimolecular colloids. When a large number of atoms or small molecules which have diameter less than 1 nanometer of a substance combine together in the dispersion medium to form aggregates having size in the colloidal range, then the colloid thus formed is called multimolecular colloid. Each atom or small molecules of the dispersed particles in multimolecular colloids are held together by weak van der Waals forces. Examples include gold salt, sulfur salt, etc. If we consider a gold atom or a sulfur atom, it has size less than 1 nanometer. A large number of such atoms combine together to form aggregates which have the size in the range of colloids, and thus multimolecular colloids are formed. Macromolecular colloids. The molecular size of certain substances like starch, proteins, cellulose, etc. lie in the range of colloids. The solutions of these substances in suitable solvents are called macromolecular colloids. Synthetic macromolecules include polyethylene, nylon, polystyrene, etc. Usually macromolecular colloids are lyophilic in nature, whereas multimolecular colloids are lyophobic in nature. Certain substances behave as normal electrolytes at low concentration, but they behave as colloidal solutions at a concentration higher than a critical concentration, which is called critical miscellany concentration. The colloidal behavior is due to the formation of aggregates of small particles. Such aggregated particles are called miscellae, and the colloid thus formed is called aggregated colloid or associated colloid. Best examples are soaps and detergents. In the case of soap can be represented as RCONA. It is the sodium salt of higher fatty acids. where R represents the nonpolar hydrocarbon chain and COO minus Na plus, which is the hydrophilic end. The anions RCOO minus aggregate together to form clusters of colloidal dimensions, which may involve a number of water molecules also. The structure of these anionic micelles in aqueous medium are approximately spherical, and each micelle has a nonpolar hydrophobic tail which is directed towards the center, and the polar hydrophilic tail CO minus is directed outward, and this is solvated by Na plus cations. Thus the soap micelle is formed at a critical concentration. The concentration above which the micelle formation takes place is called critical micelle concentration, and the colloid thus formed is called associated colloid or aggregated colloid. These are the different types of classification of colloids.